Video notes for section 6.5. We're going to start the notes with a recap review of concepts from the last couple days, mainly looking at, again, how to factor a polynomial or find its zeros for the purpose of ultimately drawing a decent graph. And so remember, the way we'll do this is we'll first actually want to see if it would factor, like by grouping, for example, in this one, but it doesn't. And then I'm going to start generating a list of P over Q, find zeros, which will give me my x-intercepts, and then also this bigger list of all the other things that I would use for graphing. And again, when you do a polynomial function graph or graph of a function degree higher than 2 parabola, we just need more stuff so we can get an accurate graph. So we're going to begin the list with behavior. First thing we want to do is look at our lead coefficient out here, which we call Q for the purpose of making a possible list, but that's also our A value. And basically positive or negative, well, positive 2. So we're talking about a positive A value. Degree is the highest exponent, which is clearly 3, so we're talking an odd degree. This in combination, when it's positive, remember positive or our A value actually determines right side behavior. So positive is always up, so we know our right side is up, and then being it's odd, it does the opposite on the other side. So we're going to go up on the right, down on the left. Behavior, long run behavior, is important for graphing because you want to, when you get your intercepts plotted, you want to make sure that as you start to sketch through those, you finish with the long run behavior that you've determined earlier in the problem. If your graph does not match the long run behavior, either that's not correct or your graph's not correct. Extreme, remember, is generally one less than the number of zeros that we have, or one less than a degree. So being degree 3, we're thinking 3 x-intercepts most likely and 2 changes in direction. The y-intercept is found by plugging 0 in for x in the original function. So we're just going to go through quick and plug in 0. What's nice about this version of it, when you have like a non-factored version, if you think about it, if you put in 0, this becomes 0, 0, 0. Your y-intercept will actually always just be this number sitting out here. So, I mean, you don't really need to do this on paper. This is like, I can just go up here and look. In like 2 seconds, I can tell you the y-intercept is negative 2. Now, because it doesn't factor, and we're going to need to find zeros, which means synthetic testing, we're going to have to generate a list P over Q. So we're going to start by doing the factors of Q over the factors of P over the factors of Q. The factor of the same number this time. I don't know if that's a little confusing or not, but P is always the constant term. Q is the lead coefficient. So it turns out the same number, so they have the same factors. When you go to do the list, I would not leave it like this. You should actually do everything on top over everything on the bottom. So 1 over 1. 2 over 1, 1 over 2, 2 over 2. Excuse me. And then write it as the actual list, not as like this. So 1 over 1 is 1. 1 over 2 is a half. 2 over 1 is 2. And 2 over 2 is a repeat. That's another 1. So here's my possible list. There are 6 possibilities, but I know by degree there's only really 3 zeros. So we're going to start testing synthetically. I always start testing with 1, just as a generally start with 1 is always good. Then if that doesn't work, we'll go to negative 1 and so on through the list. So remember how synthetic works. We bring our 2 down, and then we do a series of multiplication, and then addition going down. And then we multiply, and then we add. And multiply, and add. Now it turns out I did get a 0, which means 1 is a 0. It's also an x-intercept. Then when you get to 3 terms, there's no reason to do any more synthetic testing because at 3 terms you have a quadratic. So I know we talked about this for the first time yesterday, but you guys get used to this. So these 3 numbers will translate to x squared, 2x squared plus 5x plus 2. How I know that's quadratic is that when you find your first 0, you've actually factored out an exponent of 1 from an exponent of 3, and 3 minus 1 is 2, so you're at quadratic. So never synthetic test on 3 terms. You can go to factoring, or you can do quadratic formula or complete the square to find the other zeros. Turns out this one does factor. And then again, I want to solve those or find those zeros because I do need x-intercepts out of that. So as you're doing this and you get this completely done, one of the things easy to miss the first time is you go do your x-intercepts and you grab these 2 because clearly you can see those and you sort of forget about the one you got by synthetic, but don't forget about that one. So your x-intercepts would be 1 from the synthetic and then negative 2, and negative 1/2 from the factoring. And then I'm going to get it sketched up here, and we'll talk about that additional point idea. Like, do I need another point, or are these going to be enough? So here's my intercepts, x-intercept, y-intercept. And then what makes me feel like I probably should do one extra point is there's enough space in here that I could evaluate at negative 1. There's enough space in here too, but having the y-intercept, I probably don't need something else in here. So I'm just going to try to figure out what's going on here. So one more round of evaluating is probably good. I'm going to plug in 1. Now that's just plugging back into the original function, and I get 2. So what that does is creates another point. It gives me a little bit of a better idea of what's supposed to be going on here. When I go do my sketch, one thing I also keep reminding myself of is behavior. So the fact that it's up on the right and down on the left, I would think about that almost really before I start, and then just how do I actually get through? Well, as I start to sketch here, we're going to do... Now I've gone through all my intercepts. Change in direction to extrema matches what I figured out earlier. Behavior matches, which makes me confident that I have the right graph. And I'm going to show you guys what it looks like exactly, and then we can compare like how close we came just by doing it ourselves. So here's the actual graph. Now compare that to what we drew. Now, the change in direction are slightly different, but they're so close that we would call this by hand anyway. We'd say this graph is super accurate for what we can do by hand. So you can see we can get really close, which is the point. Okay, that's just a recap of graphing. We're going to do a little more recapping here before we get into the new stuff. So I'm going to keep rolling with some other problems. So doing that kind of a similar problem, just finding zeros and writing the factored form without actually doing any graphing. So we're still going to go through and try to find all the zeros by synthetic or factoring or combination of those usually, and then write our factors as the final problem. So making my P over Q list, P being 16, Q being a 1. So I'm going to have this as my potential list. Again, probably there's no reason to have it over 1, so I'll just get rid of that and say, hey, there you go. And then usually, again, start with 1. Now, we're actually asking some specific questions here, so kind of guiding you, like try 1, try -2. So, most likely those will be zeros. But we're going to try those out by synthetic and see. So bring the first number down, then we go multiply, and then we go addition, and then just keep rolling through. Multiplication, addition, multiplication, addition, multiplication, addition. Turns out I get a 0. Now you also notice that when I'm going to do the second one, I don't use the original set of numbers as set in black here, or the coefficients from this. I'm actually using the set in blue. If you're doing 2 zeros in a row and you found the first one right away, you don't want to go back to the original set of numbers because you won't narrow this list down far enough to finish the problem off. So if you find 1, then you want to reuse, or I should say use that set to do the next one. So now you can see those over here. And then I'm going to go through and do my synthetic again. So multiplication, addition, multiplication this way, addition this way, and multiplication and addition. I got another 0. Now, having the 3 terms, again, remind you that means quadratic. Having this be a 0 just means that you don't have an x term, so it's going to look like this. So you got x squared, no x term, -8. And then just doing our normal solving from chapter 5, I'd set equal to 0. Add 8 to the other side, take the square root, don't forget your plus and minus, and then square root of 8 is 2 root 2, simplified. Okay, so synthetic with the first one, use that set. Synthetic with the second one, narrow it down. Again, when you get to quadratic, you're done doing synthetic. You can just solve by either factoring or like we did here, or complete the square, or quadratic formula. Those all work. And then you list the factors. So as you do go list the factors, make sure you pick up everything in here. So you've got a 0 here, you got a 0 here, and then you got 2 zeros here. Total of 4, which we know should be the case because you got degree 4. So x minus 1, x plus 2, and then my plus and minus 2 root 2. And there you go. Okay, one more kind of recap problem, and then we're going to have a second video that kind of gives us the last little bit of the new stuff for 6.5. So this is a review of solving. Again, solving you guys know how to do, and it's just to make the point about the kind of zeros you're getting. So, typical solving here, like I subtract 1 to the other side, square root both sides, square root of -1, plus and minus I. Again, subtract 9, square root both sides, plus and minus 3i. Subtract 4, square root both sides, plus and minus 2i, and then subtract 2 to the other side. You notice in all cases, plus and minus, right? And the fact that we're getting I is because we're taking the square root of a negative number all along the way here. Another version of this where you're not able to just dive in and solve, but you got to complete the square. So something that's not factorable, factors of 6, that would give me a 4, that doesn't happen. So I'm going to slide that 6 to the other side. I'm going to go half the middle term squared and counterbalance. Rewrite these 3 terms as a single factor squared, and then these 2 become this side. At this point, I'm back to basically right here, doing the same thing. So now I'm going to square root both sides. Don't forget your plus and minus. Square root of a negative is I. And then subtract that 2 to the other side. The point of these problems is not really like it's a new idea. We've done all this kind of solving already. It's to talk about what do you notice with complex zeros. The thing is, they always come in plus minus pairs. And why is pretty simple, because in every instance along the way, you were taking the square root as you were solving. which creates the plus and minus idea. Okay, that's going to be it for the first half of the notes. This is the recap review part of the notes. The next video will be the last bit, the new stuff for